Since h of omega is the Fourier transform of h of n, it follows that h of omega is a periodic function with period 2 pi. Furthermore, the exponential Fourier series expansion of h of omega with h of n as the Fourier series coefficients is also possible. So, which can simply also be termed as inverse discrete Fourier transform. So, I can also define inverse discrete time Fourier transform where h of n will be nothing but 1 upon 2 pi integration of h of omega e raised to j omega n d omega, where limits will be from minus pi to pi because that's the range of omega. So this is inverse DTFT expression. This was discrete time Fourier transform expression. This was h of omega from h of n, and this is nothing but h of n from h of omega. Now, if I assume two important things which will be basic assumption throughout the discussion of this subject, that the system under consideration is linear time invariant and h of n is real valued signal. If h of n is real valued signal, then we can do this following analysis, which becomes very important. H of omega is nothing but summation h of n e raised to minus j omega n, where n will be from minus infinity to plus infinity. This can further be written as e raised to minus j omega n can be expanded as cos omega n minus j sine omega n. This can further be written as summation h of n. I'm going to split this into cos part minus j remains outside and sine part. So this is what we get. N will vary from minus infinity to plus infinity. So you can see that we have assumed h of n to be real valued. So this h of n is real. Cos omega n is a real function already. There is no j term in the first part. I'm going to call it as hr omega, where r stands for real part. Minus, I'll keep j aside. So if I keep j aside, then the remaining term also becomes real because h of n is real, sine is a real function, and because it's multiplied with j, it becomes imaginary part of the function. So I'll call it hi of omega. So any frequency response can be split into the real part as well as the imaginary part. Now if I use plus sign here, then this minus sign will be taken inside hi of omega. So we'll define that. So in this particular definition, we have taken hr of omega equal to summation h of n into cos omega n, where n will vary from minus infinity to plus infinity, and hi of omega, this minus sign is taken in the definition of imaginary part, and along with that it's h of n into sine omega n, and once again summation limits will be from minus infinity to plus infinity. So this is what we have got. Let us look at a couple of more important properties of frequency response function.